Hi, this is Bruce from Groxio Learning, and I don't have the dog on the floor. I know you might be shocked to hear it, but the dog is upstairs with the daughter who is rarely home from college, but she's home and she is Emmy's favorite person in the world. So today we are going to talk about the concept of a tetromino. So one of the things that we often do with the Elixir language is we have this thing called a token. And think about a token not as some type of security token or thing like that. Think of it like when you were playing board games as a kid. You might have had your Monopoly token and you would move it around the board because that token helped you remember the state of the game. Well, so it is with our token. So when you have four blocks together, and these are the various shapes that we're going to be working with, those things are called a tetromino. And so we're going to have a token with a couple of different attributes in it. One of the attributes will be a shape, and you can see there's all these different kinds of shapes, but if you squint just right, they kind of look like letters. And so, in fact, if you're reading strategy forums in Tetris, you'll actually see these letters. So that the I is the tall bar, and then the J is it's kind of this backwards L, and then you have the L like a frontwards L. But if you squint, you can see the shape kind of bleeding through. But we don't want to have to save all the combinations of points in all of the places that they can be. So what we're going to do instead is we're going to move this token around the board in an easy and convenient shape to understand. And then we're going to manipulate that token as people hit, for example, the right key or the left key, or if the timer ticks and our tetromino has to move down, or the user asks to rotate the tetromino. What's going to happen is we're going to move the attributes on this. So the shape is one that'll stay the same. But we also have this combination of, or this idea of a rotation, so that if you have a shape and it has a 0 rotation, we're going to render it one way. But if it has a 90 or 180 or 270 degree rotation, we're going to render it another way. And so we don't want to have to track all these individual geometric progressions through our whole program. So what we're going to do is track our tetromino with a shape, a rotation, and a location. And for us, a Tetris board, if you look at the number of squares, they go from 1 to 10 on the x-axis and from 1 to 20 on the y-axis. And we'll list x first so that 0, 0 is the upper left and 10, 20 is the lower right. So let's go ahead and get started. If you'll recall, we were working on a point and we were kind of taking that through its paces. Now let's build that tetromino. That's a pretty major element in our whole application here. And we're going to build, remember, there was this concept of a constructor, and a constructor returns, its main job is maybe to take a few attributes, maybe not, but to return the data type for this particular module. And we're going to have a couple of different types of constructors. So I'm going to create a new file called tetromino. It's easier for you to spell. Def module, and this is Tetris. I hope I don't have to say that too often. The Tetris tetromino. That strikes me as a recipe for disaster. Okay, so one of the constructors that we create might always return the same data type. But before we start to work on these constructors, let's look at a little bit of what a structure is in Elixir. So sometimes we have something with attributes, like our tetromino with its shape, its name, or its shape, its rotation, and its location. So we want to bind what's called a struct to this module, right? And so this one is going to have a shape. And let's say that our default shape is the, I don't know, how about the L? And maybe we have a default, there's a rotation. And maybe by default, this is 0. And maybe there's a location. And maybe by default, this starts at the top middle. And maybe we'll, the top middle. And that would be what? Halfway across. And the top is 1. So maybe we would start like that. So let's see what happens. So I'm gonna recompile here. And so now I need to alias my Tetris.tetromino. So the tetromino has, let's see what kinds of functions it has. Well, one of the things it has in it is a struct. At least I think so. There we go. Yeah, okay. So the tetromino has a struct like that. And what this means, so basically, if you see Elixir putting 2 underscores in the front and the back of something, Jose, the creator of Elixir, is saying, hey, I want this to be explicit, but I don't want it to get in the way of your namespacing. So when you see something with 2 underscores, think that this is a system attribute or a system function that you should be able to use, but that won't pollute your own namespace, right? So in this case, this is the default struct. And if you'll notice, if you've been programming Elixir for a while, or even just a little while, you'll notice that the percent mustache here with the Tetris tetromino in the middle, that looks like a map. So actually, if I built this data structure like this, that is a map, right? And so we could actually get the keys from it. And the keys, as we expect, are location, rotation, and shape. So what happens if we take this struct and feed that into map.keys? And remember, this is going to become the first argument that we send to this function. Yeah, so I get the location, rotation, and shape, and I also get this struct function, or this struct key. And so if I look at that, so if I say my tetromino, this is a, what shape is this? This is a L shape. And so I'm going to say, I'm going to go back and pick up line, looks like, it looks like 19, V19, right? So I can actually grab from the history, from the IEX history, one of the lines, and there it is. So I can say L and feed that into map.keys. And so I get this struct, and let's see what that is. L dot. So this is the class name related to the structure. So in fact, there's no difference. A struct actually is a map, but it's one with a specified key. And Elixir has a couple of things that it'll do a little bit differently depending on whether something is a struct or not. And the main thing is that in some places, Elixir will enforce which keys that you're allowed to use, right? So for example, can I do this? Not, or let's say bad key, right? So that was pretty, yeah, so it's enforcing that the bad key is not found in the map, or let's see, even, what if I do a, so basically, if I try to change a key there, so for example, let's take the L and let's try to update it. So this is the map update syntax. The thing that I want to update is the L, right? And let's say that I want to update the location. And I want to set that to 10, 10. So there's a bug there. Did you catch it? I actually swapped the O and the I. But since this is a struct, it's going to recognize that this key is not available, right? So this key is not available, and so this is going to break. So the only thing special about a structure is that there are extra protections that are afforded by programmers by virtue of Elixir knowing what all the keys, what keys are allowed. But one thing that I don't want to ask of my user very often is to have to type right? I don't want them to have to type that because this is hard to remember. And so there's another version of this where if I wanted to change, for example, the shape, I could say, give me an O shape like that. And you can see that I got all the defaults, but replaced only the one thing. So I like this functionality. I don't like the name. So I'm going to go ahead and create my first constructor. It's going to be called new, right? And I might take options, but this basically says if the user doesn't specify options, I want you to provide an empty list. And so we're actually going to take this and we're going to feed that into just like that, right? And so that's our first constructor. So I can recompile. So now I have this new, or the new where the location is 10, 10. Oh, and actually this is a tuple, so it doesn't yell at me. I want to add it like that. Right, so now I get a new tetromino that's in location 0, 0. But actually, we don't get to control the individual brick that Tetris throws at us, do we? So what I'd like to do is actually, I'd like to keep the default location, right? That's fine right there. The rotation, maybe we always start in the same orientation. That might be okay, but you know, I'm quite sure that we don't always want to give Elixir the same, to give our Tetris game the same shape. So it would be boring if I just piled down the same shapes over and over. Unless it was a Z, that might be a difficult game, right? Okay, so what we're going to do is we're going to build a new constructor for random elements. So this is one that I would use perhaps if I'm debugging or perhaps in my tests where I want something predictable. And this is the one that I'm going to use for the game. So I'm going to say new, and I'm going to say the shape, and let's say, yeah, that's enough. I think that we'll choose the rule that our rotation will always come through at 0. So now I need to write this random shape function. Okay, so random shape doesn't take any arguments. And when you're defining a function, you don't necessarily need the parentheses. When you're calling it, you do, because Elixir wants to be able to tell the difference between a variable or an argument or a function. And the way to do that is by enforcing the idea of parentheses. So that's a good habit to get into. But what I'd like to do is to provide a list of all the possible shapes. So let's talk about how we'll list them. So what are the shapes? So I could make a list like this. 1, 1. So those aren't the actual Tetris shapes, but I just want to illustrate a point here. So I can make a list like that. That's a lot of noise for your eyes to process. And it turns out that there's something called a sigil, which is basically a little bit of syntactic sugar, where I could say, give me an array of words, right? And the words in this case are A, B, and C. And so you can see that this gives me a list of A, B, and C, but they're not atoms. But it turns out that I can tack some options on the end like that, right? So now I get this list of options. And so this is a bit easier to read than this, right? And the only penalty is you have to know what this thing is on the front end. And since this is going to be a list, and I can choose which delimiter that I use with my sigil, I'm going to represent my sigil like this, right? A, B, C, right? And that's going to be atoms like that. That's beautiful. So these are the ones that we need. Let's see, we have the O shape, the L shape, the Z shape, the S shape. L actually has a J also. And then the skinny one is the I, and then there's also a T. Is that it? Is that 7? 1, 2, 3, 4, 5, 6, 7. That's it, right? So those are the ones. And I can basically pick a random one. So I know that, so let's explore a little bit. So that last thing that I typed, let's get the information about it. So Elixir says that this thing is a list. So I might find something in the list module. So I could say, give me the exports for list. And there's a bunch of stuff in there, not really that many things. And it doesn't look like there's anything related to random. You know, I'm looking right here. So, but there's also, so let's look at the, at this guy again, and let's inspect it again. So there's also implemented protocols. So I know that this thing is an enumerable, and I know that there are additional functions that are in enum, right? So I'm going to say Elixir give me the exports for enum. And sure enough, you could see that there's a random. And so we could say, give me the help for enum.random. And it says, okay, give me a random number from 1, 2, and 3. And this time it provided a 3, and this time it provided a 2. That looks like exactly what we're looking for. So let's grab this. And let's feed that into enum.random, just like that. And so that ought to give me a random shape. And you might be asking yourself why I listed this P. Well, it turns out that the only function that's going to need, the only module that's going to need this function is this one right here. And it's a nice thing to be able to say, to be able to look at a module from an external perspective and say, what are the types of functions that I will potentially need to be able to use? And those are the functions that are exported. So like when I said exports here, what functions does list export? Well, there are probably a couple of dozen extra small helper functions within list that we're not using at all. That aren't exported at all. And it's nice to be able to, for us to see only the ones that are required. And so I think that this is probably a good start for our constructors. So recompile. And let's say, so tetromino.new random. And that gives me a location, always 5, 1. It gives me a rotation of 0 and a shape of S. And if we do it again, yeah, look, we're getting additional shapes in there. And so this is probably a nice place to start for us. I've coded this game in the past where the rotation was also random. In this case, I think we're going to leave it alone, and that'll be great. So this is probably a good place to stop and take stock. we've coded our constructor, and remember, a constructor creates the data type, which for us is a struct for this module. So this returns the struct. This is one that returns predictable structs, and we might use this in a test case where we want to be able to predictably produce the same result. And this is a random one, which might be more fun for a game. And this is just a private function. So we're going to keep those at the bottom, and we're going to keep our exported functions listed first. And that way we can tell what our major API needs to do. So next we're going to code, in the next module, we're going to code a few reducers. For example, write will take a struct and change it to a struct that's moved to the right one, to the right one square, or move to the left one square, or move down one square. And you might know exactly how we plan to implement that because we already have our reducers on point. So we left our application in this condition where we had this module, and the module is a Tetris tetromino. And so let's go ahead and alias this thing. Great. Just in case you haven't already done so. And we have these two constructors. And remember, a constructor is something that creates the initial data for a module which takes a given type. And our data is a struct. And remember, a struct is just a map with that extra struct key in it. And so we were going to code this reducer, right? So this is going to take, this time, not a point, because we're in the tetromino. This is going to take a tetromino. So I'm going to call that a tetro. And we're going to update this. Let's see how that works. So I want a tetro. I'm going to use my constructor, and I'm going to update this with the map update syntax. So tetro. And I'm basically, if I want to move this to the right, I could set a new location. And I could say 6, 1, right? And you've seen that tetro, that hasn't changed, right? Because Elixir is immutable. It's not going to allow actually the struct that we created in the first place to change. That'll remain the same forever. We could rebind the variable, but that's another discussion. Let's not get lost there right now. But right now, what we're doing is we're creating a new structure that is moved one square to the right. So that's what we're going to do here. But you might say, hey, Bruce, didn't we write a function to do exactly that work? Well, yes, we did. Now I'm going to create a little error in here. I'm not sure if that's what the formatter would do, but I like it like that. So I'm going to say point.write Okay, so I'm going to use the map update syntax. Now I'm going to add a little error in here. I'm not sure if that's exactly what the syntax formatter would do, but I like it like that. And I'm going to set a new location. And I'm going to take the existing location and I'm going to move it to the right. So that does, I think I'll tighten that up just because I think it'll conform a little better. Okay, so now this is moved to the right. What this does is create a new tetromino that's moved to the right using the reducer that we've already created here. But remember, we're going to have to alias this so that we can refer to it as point, just so we don't have to do all of that extra strong typing. So there's my alias. And you might say that the shape of this is going to be pretty similar for left. Actually, let's do this. And for down. Yeah, so I like that pretty well actually. And so now we can move these things around. So we ought to be able to play the same game with our reducer that we did before. So let's recompile this. Let's see, undefined function point. Oh, yep, these are tetras, aren't they? Holy cow. Let's see if we, oh, there's the point definition there. These are tetros. Okay, so now let's recompile. Now it's happy, so I could take the tetro that's still hanging around for me, and I can basically pipe that to I can move that to the right, and look. I can move that to the right, and look. It's moved one square to the right. So let's move it down also. So this is a beautiful way to tell a story with my code. And so these are the reducers for down. So I need to be able to move it. I also need to be able to rotate it, don't I? So let's go ahead and add that. And I need a tetromino. And so one of the things that we can do is do a pattern match and look at the degrees that are already in there. So let's do it this way. Let's build some private functions. So I want to rotate degrees, and if it's 270 degrees and I'm rotating it right, I want that to be 0 degrees. And if I'm rotating in degrees, I want this to be in plus 90, right? So here's how this works. So I've defined these with def instead of def p, so you could see what's happening here, but then we'll make them private. Dot rotate degrees. And so if we pass it in as 0, it's going to match this one, and it's going to give us 90 back, right? So, and 0, and then I can pipe that, and I can rotate it. What happens if we rotate that much? If we rotate it that much further, right? And if we rotate that again, it keeps going around. And so that's the behavior that we're looking for. But what if we rotate from 270? Well, we're going to match the first function instead, and it's going to wrap us back around to 0, which is the behavior that we're looking for. So let's make these private because nobody else needs to be able to see those. And we're going to implement our rotation now. So we're going to grab this form, right? So we're going to rotate the tetro, and this time we're going to change the rotation. I tell you, I really like some space in there. So rotation, I'm going to do I'm going to do rotate degrees, and I'm going to say tetro dot rotation, right? So now we can, every time that we hit the rotate key, we could just pass our tetro in, and it's going to rotate it again 90 more degrees. So I'm going to recompile, and that's happy. So I'm going to take my original tetro, and I'm going to pass that to I'm going to rotate that. And look, it's 90. And I'm going to take that and I'm going to rotate that much again. It should come around to 180. And I'm going to rotate that again. And it should be 270. And I'm going to rotate it just one more time just to make sure it wraps around. And yes, we're all the way back around to 0. So these are reducers. And you can see that Elixir is already starting to reward us because we can set up this beautiful pipeline that tells a story. Tetro, rotate, rotate, from 90 gives me 180. And that's a beautiful thing. It's going to help us understand quickly what our code was doing with a quick scan. And this is going to be much more important when we start to do some of the more complex geometry. This is Bruce from Groxio. This is a great place to stop and take stock.